In this video, we go about focusing on how we go about naming amides using the IUPAC nomenclature system. Remember that amides are molecules that have a carbonyl group, and that carbonyl group is directly bonded to an R group, where R here is a carbon chain, or a hydrogen there, or carbon ring, whatever you want. Carbon-containing group there as the R group. And the carbonyl has to be directly bonded to a nitrogen atom. If it's directly bonded to a nitrogen, it's going to be referred to as an amide group, as long as that nitrogen is directly bonded to a couple of R groups here, where I'll call these R prime, and these can be hydrogen atoms and or carbon atoms there. So these are going to be our amide functional groups, which the focus of this video is how we go about naming structures that have amide functional groups present in them. So let's take a closer look at this. As we talk about IUPAC nomenclature of amides, we need to make a distinction between the different types of amides that you may run into. There are three basic types of amides: primary, secondary, or tertiary, which we also refer to as just unsubstituted amides, N-substituted amides, and N-disubstituted amides for primary, secondary, and tertiary amides respectively. So let's draw out what we mean here when we say a primary amide. A primary amide, first degree amide here, is going to refer to a structure where we have our carbonyl group. Carbonyl is directly bonded to R, where our R is a carbon or hydrogen over here. And then the business end of this molecule, what makes this an amide, is that we have a nitrogen here directly bonded to the carbonyl. And this is referred to as a primary amide if this nitrogen is part of an NH2 group. So the primary amide, much like the term primary has meant in the past with primary amines, for example, means that there is only one bond between nitrogen and any other carbon atom. So this carbonyl nitrogen bond is the only carbon-nitrogen bond here between this nitrogen and elsewhere. So that's that. Then from there, we can look at a secondary amide. So in a secondary amide, we have now our nitrogen, rather than being an NH2 group, it is an N directly bonded to one H atom and also to another carbon atom. So this R here refers to a carbon that's directly bonded there. And so therefore, this is referred to as a secondary amide because of the fact that it has two direct bonds between nitrogen and carbon atoms. That is, the nitrogen is directly bonded to the carbon here. It's directly bonded to the carbon here as well. This is also referred to, synonymously to secondary amide, is it's referred to as an N, and that N is italics, by the way. Not a big deal, but it helps designate it. The N refers to nitrogen there by making it italicized. It's an N-substituted amide. And the reason we call it an N-substituted, and I better work on my spelling here of substituted, it's an N-substituted amide because of the fact that the nitrogen atom here is not just bonded to the carbonyl carbon, but it's bonded to this R group carbon as well, and we refer to that as the N-substituted portion. And hence, this secondary amide is synonymously an N-substituted amide. And then, analogous to that, we can look at a tertiary amide as an N disubstituted amide. And we'll draw out an example of that. So in this structure, our nitrogen is directly bonded not to just the R prime group here and one hydrogen, but instead there's no hydrogens directly bonded to this nitrogen. And there are two R groups where those could be the same or different. And the trick or the key is that those two R groups have to be two carbon atoms. And so hence, this is referred to as a tertiary amide because of the fact that the carbon atom has 3 nitrogen carbon bonds, and synonymous to that, it's referred to as an N-N disubstituted amide. And as an N-N disubstituted amide, that's referring to the fact that this nitrogen is directly bonded to 2 carbons other than the carbonyl group. So when we are naming amides, the rules for naming these different amides is going to vary just a bit based on whether you're dealing with a primary, secondary, or tertiary amide. Because when we're dealing with secondary or tertiary amides, we're going to have the extra consideration that we have to be able to specify what the identity is of this carbon-containing group that's directly bonded to the nitrogen atom, or multiple carbon-containing groups bonded directly to the nitrogen atom here. And so that's going to result in some extra complexities with naming secondary and tertiary amides relative to primary amides. And so that's why we need to quickly be able to look at an amide and say, okay, we're dealing with a primary one here, secondary one, or tertiary one. So let's go ahead and dig in deeper into this IUPAC system of nomenclature of amides. So to name primary amides, for starters, the way that we will name a primary amide is that we will take the name of the corresponding carboxylic acid, meaning that if you had an OH group rather than a nitrogen present attached to the carbonyl, how would you name the molecule? Drop the ic acid or oic acid suffix from that name and instead tag the name with the word amide. So I'm going to go ahead and write that down, and keep in mind that we are referring to these as derivatives of carboxylic acids. We likewise use the carboxylic acid nomenclature system as a way of anchoring us for naming these. So what we would do is we would drop the ic or oic acid portion of the carboxylic acid name. So we drop the oic acid from the corresponding carboxylic acid name and replace it with the term amide to indicate that the molecule has an amide functional group present in it. So as a result of this being the nomenclature system, we are very much using rules for naming these primary amides that were completely analogous to the rules that we used for naming carboxylic acid molecules. And like carboxylic acids, if we have an amide group present in our molecule, the amide group is going to be the highest ranking of the groups that we will run into. So let's go ahead and determine the name for an example primary amide molecule. So I'm going to go ahead and draw out a structure here. So this is going to be our molecule we'll start with. And we recognize this straight away as a primary amide because we have an NH2 group here. There's no carbons directly bonded here to this nitrogen other than the carbonyl. So this is a primary amide. And to name it, keeping in mind that the corresponding carboxylic acid would have that same length of carbon chain, like so. And carbonyl group, rather than the nitrogen there, would have an OH group. And that corresponding carboxylic acid, being that it had a chain of 1, 2, 3, 4, 5 carbons, would be pentanoic acid as the parent name for the carboxylic acid. We instead, for the amide, refer to this as pentanamide. So pentan, removing the oic acid part from the name and replacing it with amide gives us pentanamide. So rather than pentanoic acid, pentanamide, because we have dropped the oic acid part of the name. So in other words, we dropped this oic acid part of the corresponding carboxylic acid name and we replaced it with the term amide. Now, just like in naming the corresponding carboxylic acid, we have to identify the branches as well. In the case of the carboxylic acid, we had a methyl branch two methyl branches, in fact, at position 4. Same thing over here. We have two methyl branches at position 4, and so we need to name those. So we'd refer to that as a 4, 4 dimethyl pentanamide molecule. And we could name whatever branches were coming off of this chain using the rules that we've talked about all semester and all year long. So just as a recap, we number the longest carbon chain beginning at the carbonyl group of the amide, 1, 2, 3, 4, 5. And then from there, we determine the parent name, where the parent name is going to be analogous to how we would have named a carboxylic acid if we had an OH here instead of an NH2. And so the parent name here would be pentanamide with that NH2 rather than pentanoic acid if we had an OH there. And then from there, we come up with the location and name of the branches. So at position 4, there's two methyl groups, so we call it a 4,4-dimethyl pentanamide here. As the way of going about naming primary amides, it is as straightforward as taking the carboxylic acid name and replacing the term ic or oic acid with the term amide. Let's take a look now at naming secondary amides. Specifically, when we are naming a secondary amide, the challenge that we're going to run into is when we're naming a secondary amide, we have alkyl groups directly bonded to the nitrogen atom. So with our secondary amide, we have our nitrogen, and then we have one hydrogen, but we also have an R group here that I'm calling R prime, and we need to name that group. The way that we are going to name that group is that we are going to name that group as a so-called N group. An N technically is in italics, so we'll name this as an N-alkyl group. And the N there will specify that this branch that we're referring to comes off of the nitrogen atom directly, hence making it an N-alkyl branch. So that N term allows us to distinguish the branch that's coming directly off of the nitrogen from any branches that we would have associated with our carbon chain that comes off of the carbonyl over here. So in order to name a secondary amide, the general layout is this. We will name these the same way as we would primary amides, but the difference is that we will treat the alkyl groups that are directly bonded to the nitrogen as branches coming off of that nitrogen, specify their position attached to that nitrogen by using the prefix N. So name the molecules as primary amides using the rules we were just looking at, and treat the N-alkyl groups as substituent or as branches coming off of the molecule, using the prefix N to indicate where those are located. So let's go through an example of naming a secondary amide. So here's the example we'll take a look at. I'm just drawing out our amide example molecule here. I always encourage you to hit the pause button after I have finished drawing this to see if you can draw this and come up with the same outcome that I do in terms of the nomenclature here. So we'll go ahead and just draw out this full structure here. Drawing myself a 5-carbon ring right here directly bonded to our nitrogen atom there. So determining the IUPAC name for this particular molecule, keeping in mind that we will name the portion of the molecule that has our nitrogen and our carbonyl group and whatever is bonded over there, we would name that as an so-called alkanamide, using the same rules that we would for naming a carboxylic acid if we had a COOH group here, except that since it's an amide, you replace the oic acid part of the name with the term amide to indicate that we have this amide group here. So naming this as an alkanamide, we number our longest carbon chain, starting at the carbonyl as number 1, just like we would start at number 1 as the carbonyl carbon of a carboxylic acid. We find our longest pathway through 1, 2, 3, 4, 5, 6. So there's 6 carbons in that longest carbon chain. So therefore, the parent name for this molecule, and I'm going to leave myself some space, so I'm going to start over here at the very right-hand side of the screen, is going to be hexanamide. Now, the term hexanamide is only referring to our 6-carbon chain, which I'm highlighting here now, as well as the carbonyl group and the nitrogen that's bonded to it, because that's what gives it the amide portion of the name. Now we need to go in and name the branches that are coming off of that longest carbon chain. So at position 5, we have a chlorine branch. At position 4, we have a methyl branch. So I'm going to go ahead and sketch in the names of those so that we have those handy for later. So this is going to be a 5-chloro and a 4-methyl. And we'll keep those handy because when we go to list the names of all the branches here at the beginning, we will include the branch over here that's bonded to the nitrogen as one of the branches that we include in our alphabetical lineup here. So that's why I haven't written the chloro and methyl groups out here in the name just yet, because those are going to get rolled in to the alphabetical order along with this so-called N-alkyl branch that we are going to be naming, whatever that group is that's bonded directly to the nitrogen. So let's go ahead and tackle that puzzle. So directly bonded to the nitrogen, this N-alkyl group that we have here is a cyclopentyl group, and so we would call this an N. An N technically is an italics dash cyclopentyl. So you could think of that N as being like having a number there to indicate the position of that cyclopentyl group, but the N here is designating that that cyclopentyl is directly bonded to the nitrogen of the amide. So now that we have accomplished this, what we need to do is go ahead and fill in alphabetical order, the positions of the chloro, methyl, and cyclopentyl branches. Now, when alphabetizing these, we do alphabetize based on the term cyclo and cyclopentyl, at least based on the current IUPAC rules. So we're going to go based on the C in cyclopentyl, the C in chloro, and the M in methyl. Of chloro and cyclopentyl, chloro comes first in the alphabet, so therefore I'm going to list chloro first in the name here. So it's going to be 5-chloro dash N cyclopentyl, because again, we're treating that N just like it were a number here. So we don't consider that N when we're alphabetizing. We do consider the cyclo, because based on the rules, cyclo is one of the terms that is considered when alphabetizing. And then finally, 4-methyl, and that term methyl runs right into the term cyclo, turns right into the term hexanamide. So our complete name for this, except for the stereochemistry, which we'll get to in just a second here, the complete name for this so far is going to be 5-chloro N-cyclopentyl 4-methyl hexanamide. And then we need to go ahead back in here and determine the configurations where possible. So we have 2 stereocenters in here at position number 5 and position number 4. Both of those have wedges and dashes shown, so therefore we can assign the RS configuration at both of these locations. So we will do that just like we have done all along, meaning that once we fill those in, we're going to add that information at the very beginning of the name here. So at the very beginning of the name, I'm going to go ahead and fill in as my template position 4 and leave myself a space to fill in whether that's RS, and position 5 and leave myself another space to fill in whether that is R or S. So at position 4, we determine the 4 groups that are directly bonded there. We have a carbon, another carbon, and then the hydrogen's pointed away from us and invisible in this diagram. So highest ranking group is going to be coming over here to the left because that has a chlorine directly bonded one more position away. So that's going to be the highest ranking. So going from highest ranking to second highest ranking to third highest ranking would take us clockwise. Since the hydrogen points away from us, clockwise is going to indicate R. So I'm going to fill in 4R. And then at position 5, our highest rank group is that directly bonded chlorine. Second highest rank group comes over here toward carbon 4. Lowest, or third highest ranked group rather, is coming over toward position 6. So that takes us clockwise, but keeping in mind the hydrogen points toward us here rather than away from us, that means that that clockwise arrow is going to indicate S as the configuration there. So our complete name for this, now not forgetting the stereochemistry, is going to be what I have highlighted here in yellow toward the bottom of the screen. Onward to our last example here. And as you might have guessed, since we've already done primary and secondary amides, now we're going to do a tertiary amide. And the way to go about naming a tertiary amide is completely analogous to how we named a secondary amide, except that we're going to have not one, but two N branches, due to the fact that in this tertiary amide, we have R2 here. I'm going to call that R2 prime, and those two R groups could be identical or they could be two separate carbon-containing groups here. And so each of these is going to be referred to as an N group. So we'd have N-alkyl, based on whatever one of those two carbon-containing groups was called, and then another N-alkyl group, indicating whatever the other nitrogen-containing group or alkyl group was that was coming directly off of the nitrogen there. So let's go ahead and draw out an example and work to determine the full IUPAC name of that molecule based on what we know about the fact that the two nitrogen branches are going to be both named as N-alkyl groups in the name of these molecules. So as our example here, let's go ahead and look at this problem. I'm going to go ahead and draw out my structure, draw my amide functional group, which I'm going to plug a couple of different groups on here. Once I get this drawn out, I encourage you to go ahead and hit the pause button and give this a try on your own, and then hit play to see whether you got to the right answer for this or not. So I'm going ahead and drawing out this complete structure here. And in this complete structure, we'll go ahead and find our longest carbon chain to come up with the parent name for this molecule, remembering that the parent name is going to be determined based on starting at the carbonyl group of our amide. That parent name is also going to incorporate the nitrogen atom that we have there, because it's going to have the suffix amide on the name. So finding our longest carbon chain, I trace through here like so, and I find out how many carbons are in that longest carbon chain. So we start here at position 1 is always the carbonyl, 2, 3, 4, and 5. So therefore, the parent name for this, which I'm going to put all the way over here at the right, is pentanamide, because that parent name is always going to correspond in the amide to the carbonyl group headed over in the direction opposite where the nitrogen is. So we get that as our longest carbon chain here. Now I'm also going to catalog the branches coming off of that longest carbon chain that we've highlighted in pink. And those branches are, we have a carbonyl group here of an aldehyde and a carbonyl group of a ketone at position 4 and 5. Remember from our earlier work that both of these groups are referred to as oxo groups. So this would be a 5-oxo group, and this would be a 4-oxo group. Carbonyl groups, when they are in aldehydes or ketones, and their branches coming off of a molecule such as an amide that's higher ranking in determining nomenclature, are going to be named as oxo branches. So we have both of those oxo branches. I'm going to hang on to that knowledge for now, because we are ultimately, like we did in the last example, going to plug those in as prefixes into the name of this molecule and alphabetize those along with the names of the so-called N-alkyl groups. That is the alkyl groups that are directly bonded to the nitrogen over here where I'm highlighting now. So now we need to name those two N-alkyl branches. So naming those two N-alkyl branches, we have a methyl group here directly bonded to the nitrogen. So we would refer to that as an N-methyl group. And additionally, we also have this group directly bonded to the nitrogen as well. And you could refer to that as an N-isobutyl group would be the most prevalent way that people would typically recognize that, because it's a 4-carbon group in total, and it has this iso group at the end. That situation where we have a methyl group coming off of the next to the last carbon of the chain here, going away from the parent part of the molecule. So we name that as an N-isobutyl group. We could also synonymously refer to that using a system of coming up with the name based on the longest carbon chain within this group, within this branch. So that would be a 3-carbon chain, because we start numbering from the carbon that's bonded to the nitrogen. So a 3-carbon chain is referred to as a propyl group. And so I could go ahead and write out the term propyl. And at position 2 of that 3-carbon chain right here, there's a methyl group. So I could refer to that as a 2-methyl propyl group. So if I wanted to use this terminology, what I would need to do is put that all in parentheses and then put the N designation in front of that so that it was clear that everything in parentheses was what was directly bonded to that same nitrogen atom. That all of that nitrogen is directly bonded to the 2-methyl propyl group, also known as an isobutyl group. So you could name this as an N-2-methyl propyl group like I've done here, or isobutyl group. I'll use the isobutyl group for purposes of our example, but the other scenario would be perfectly acceptable as well. So now we go ahead and we are going to plug in our branches into the prefix of this name. So we have oxo, oxo, N-methyl, and N-isobutyl. Alphabetizing those and plugging them in, what we will do is we will have, coming first in the alphabet, remember that we do use the term iso when alphabetizing, so therefore iso comes first ahead of the other letters that we are looking at here. So N-isobutyl. After that, M comes before O, so N-methyl. And then finally, since we have 2 oxo groups, we'd refer to this as 4,5 dioxo, since there's 2 of those carbonyl groups, pentanamide. So highlighting out the full name for this molecule in orange here is going to be our complete IUPAC name for this. There are no stereocenters in this molecule, kind of surprising despite the complexity of this structure. But if you look, there are no carbons that have 4 different groups directly bonded to them, and there's no alkene groups in here that could be stereocenters either. And so we are good to go here. So based on the information in this video, you should now be comfortable with whatever amide molecule I might throw at you and ask you to determine the IUPAC name of, whether it's a primary, secondary, or tertiary amide. You should be equipped to name that molecule using this alkanamide terminology to refer to the parent chain that contains the carbonyl and the nitrogen of the amide group, and naming branches that are coming off of the nitrogen atom as N branches in the beginning of the name.